data centers, and cloud storage. Did you know they use a lot of water to keep the systems cool? Fresh water, the lifeblood of our planet. It plays a crucial role in supporting ecosystems, human civilization. It is crucial to daily activities, and its scarcity is intensifying. It becomes imperative to safeguard its usage. So I'm going to look into potential solutions and the realm of sustainability regarding data centers. There's a system that's called immersion cooling. So we're going to look into the benefits and the companies that are adopting this type of cooling. So we all know that fresh water is valuable. It is essential for our survival, but also fuels food production, energy generating, manufacturing, and sanitation. Despite covering 2/3 of the Earth's planet's surface, only a minuscule 3% of it is fresh water. Pollution has rendered rivers and lakes undrinkable, threatening both wildlife and local communities, although, it's getting better. Overuse driven by population growth triggers water shortages. And have you heard about what's happening with avocados and Spain and their droughts, but people wanting to make avocados which use a lot of water? Do you eat avocados? They're really tasty, but should you? Fresh water access is poised to become a defining issue for future generations. Now, there is lots of seawater, and there is a way to do desalination, to remove the salt from the water. Is this a feasible way to create more fresh water? Let's have a look into this. This process involves two primary methods. There's thermal and membrane processes. Both generate fresh water from seawater. The disposal of the byproducts, notably it's called the brine, possesses environmental challenges. Innovations are underway to extract valuable minerals from the brine, repurposing it for applications such as baking soda, production and carbon dioxide capture, contributing to a more sustainable future. Well, it sounds good, right? And there are companies that are using renewable energy powered desalination with sources from solar and wind power that are helping by using green energy. Power use globally. Data centers currently use approximately 1.5 to 2% of the world's electricity. Several models suggest that data center energy use will increase, accounting for 13% of global electricity use in the next decade. Up to 40% of a data center's energy consumption goes into cooling. As dozens of servers stacked on top of each other can get very hot, and the power density of the processors continues to increase, server platforms are pushing the limits of what you can cool with air. This energy use is of dire concern if they are not potentially mitigated by using green energy. In reality, over 60% of the world's electricity is still produced from using fossil fuels with carbon emissions. So with sustainability in mind, the global trend in the upward direction of the data centers, the value of environmentally responsible operations are an increasing concern for government regulations. Sustainability is high on the agenda for many corporations. Some customers will not even consider working with a company that is not taking action on reducing their impact on the environment. There is growing awareness of how operations impact the environment, including the power brought into the data center, how much of that is actually used for computing work, and how much of that energy is wasted. Heat pumps come into mind where you can repurpose the power from the heat. 3/4 of data centers are right now thinking about the importance of sustainability as a competitive differentiator. To keep up with demand, data centers are implementing more powerful computing resources, which consume more energy and rapidly expand into organizations' carbon footprint. The increasing dependency on internet-enabled devices is likely to drive increased electrical use and significant environmental impact in data centers. It's expected that by 2025, 152,000 new devices will be connecting to the internet every minute, bringing the total to about 80 billion worldwide. That's a lot of data. And even as the data centers are aware of this energy use challenge, they haven't been able to move the needle much. The average data center has hit a wall in power usage effectiveness, which has been hovering at around 1.6 for almost a decade. Fresh water is so important to have on our planet. It is vital for life, supporting ecosystems, human civilizations. We use fresh water in many aspects of daily life, including food production, power generation, manufacturing, and sanitation, for example. However, it is becoming increasingly threatened. Although the Earth's surface is two-thirds water, less than 3% of that is fresh. And there's been so much pollution in the rivers and the streams and the lakes that makes that water unusable and also harms the local wildlife. Overuse, triggered in part by population growth, causes water shortages and dries up lakes and rivers and the streams before it reaches the sea or its downstream neighbors, sometimes causing conflict. Access to fresh water is gonna be a defining issue for future generations. And talking about conflict, have you heard about what's happening with avocado farming and the overdoing of that in certain regions, especially in Spain, where they are very short on water, but there are farms that want to produce massive amounts of avocados because they sell well, because they're a wonderful vegetable, and they're healthy and good for you, but they are not healthy for the planet if they are mass produced because of the amount of water that they need. And in drought places, this is not a good thing. Now, we can desalinize seawater to produce fresh water. The desalinization process is possible. There's two methods. There's a thermal method and a membrane process. So the thermal process is heating the seawater to produce steam, which is then condensed into fresh water, leaving behind the salt. And the membrane process involves forcing seawater through a semi-permeable membrane that separates the salt from the water. So the brine, which is the leftover, is usually disposed of by returning it to the sea, as it increases the salinity and the temperature of the seawater, reducing oxygen levels and harming marine life. Therefore, we need to come up with a more sustainable and innovative way to manage this brine waste and minimize the environmental footprint. So repurposing is one way of doing that. And also the minerals within it can be valuable. There are metals and chemicals that can be extracted to used for various applications. Some researchers are developing a process that uses the brine turned into baking soda and calcium chloride, which can also be a factor in capturing carbon dioxide from the air. This process not only reduces the amount of brine disposal, but also helps mitigate climate change. Yay! By removing some of the gases from the atmosphere. And another possible solution is to use renewable energy sources such as wind and solar power to drive desalination processes, which is a good idea. This can reduce the reliance on fossil fuels and lower carbon emissions associated with desalination. Some examples. So countries that are doing this, we've got Saudi Arabia with its abundant solar energy resources. Saudi Arabia has invested in large-scale solar-powered desalination plants. These facilities harness the country's intense sunlight to generate electricity for desalination, making it a significant contributor to sustainable water production. So like Saudi Arabia, we have the UAE, United Arab Emirates. They have taken advantage also of the sunny climate to implement solar-powered desalination projects. The UAE has been in the forefront of innovation in this field, deploying renewable energy sources to address its water needs. Australia, known for its commitment to renewable energy, has also adopted green power for desalination. Solar and wind energy have been integrated into their processes for the region facing water scarcity. Spain also strides in utilizing solar power to power desalination plants, particularly in the regions with limited freshwater resources. Solar power plants for the desalination aligns with Spain's efforts to promote clean, green energy and efficient water management. And following suit, we've got Israel, Chile, India, and Kuwait. These guys are well into desalination and are using green energy to help produce it. And all this talk of water brings me to data storage and things like ChatGPT. They use a lot of water to keep their systems cool. So, for example, if you were to ask ChatGPT 20 questions, that uses 500 milliliters of water, which is half a liter for just 20 questions. Which you might think that's not bad. I guess it's fine. Is there a different way to do the cooling other than using our freshwater resources, which we're busy in the world trying to extract from seawater and trying not to overuse? Is there another way? One of the most environmentally friendly data cooling systems is liquid immersion cooling. This system involves immersing servers and other data center components in a non-conductive fluid. This efficiently absorbs and dissipates the heat generated by the hardware. So, looking into it, there are benefits of this cooling system, which include the process being highly efficient as the liquid absorbs the heat directly from the components, eliminating the need for traditional air cooling methods. It reduces the carbon footprint as the energy is not as much as using the traditional air cooling way. It is a space saver as it allows denser hardware configurations and eliminates the need, because there's no air cooling needed around it because it's all immersed in this liquid. And it's not as noisy because there isn't the huge air circulation fans going on. So the cons of this are it can be complicated to implement liquid immersion cooling systems as it requires significant changes to the existing data infrastructure. Servers and hardware components need to be specially designed or modified to work effectively in a submerged environment, which of course costs more. So the upfront cost of this liquid immersion cooling system can be higher than setting up an air cooling method, as you need the special components and the fluids, and it all has to be set up quite differently, which all adds to the cost. And there's a risk of fluid leakage, which can lead to contamination of hardware components or the surrounding environment. Proper maintenance and monitoring are essential to prevent leaks and ensure the integrity of the cooling system. So while liquid immersion cooling can reduce the need for traditional air cooling mechanisms, it introduces new maintenance challenges. Regular checks and upkeep of the cooling fluid, filtration systems, and equipment are essential to ensure optimal performance and to prevent issues, so you need specialized people to look after this. This cooling system is not compatible with all types of hardware or server configurations. Some hardware components might not function efficiently or safely if submerged in an environment with the liquid, limiting the range of the systems that can benefit from cooling. And also, while the heat is collected from the hardware components into the liquid, then dissipating the hot liquid to make it cool again can itself be a challenge. Efficient heat exchange systems are required to prevent overheating of the cooling fluid, which can lead to reduced cooling effectively if it's not done right. And it's not quite as scalable and easy to do as air cooling. It also has issues of the fluid itself, which, if not handled properly, and if it gets back into the environment, or if it needs to be disposed of in some way. So in some ways it is a good thing, as it doesn't use up the water and all the other pros that I mentioned, but it does have a bunch of cons. So hopefully more systems will be coming into future use, more innovations appearing, let's hope, as data storage and the use of data and these enormous complex systems that are only growing, like the cloud isn't actually up in the clouds, it's on the ground and using lots of power and lots of water to keep it going, and that is just going to get more and more prevalent as more people want data. And there are some companies using that. We have Submer, which is a company that specializes in providing liquid immersion cooling solutions for data centers. They have implemented their technology in various data centers worldwide. And then we have Cloud and Heat Technologies. This is a German-based company that offers data center solutions that incorporate liquid immersion cooling to improve energy efficiency and reduce environmental impact. Bitcoin miners. There are some large-scale mining operations that have adopted immersion cooling to increase mining efficiency and lower energy consumption. So, sustainability, how can this be achieved in data centers? First, understanding how the energy is used as it is divided between the infrastructure server load and reducing the environmental impact, finding ways to reuse the heat that is wasted and reduce the power demand. The removal of internal server fans reduces the energy load by 10 to 15%. And that would be with using the immersive liquid method. So that would be the use of the immersive cooling system. For the air cooling the traditional way, water plays a significant part. So, data storage and water usage. Water acts as an intermediary heat carrier, where cold water is channeled through heat exchangers positioned within or near the server's airflow path. As warm air passes over these exchanges, heat is transferred into the water, which is then pumped to an external cooling system like towers or chillers for heat dissipation. Cooled water cycles back to the heat exchanger and the process is repeated. Water is great at conducting heat. So as we need more innovative ways to cool these data centers that seem to be becoming more and more important, so water is essential for the inhabitants of the earth. We need it, basically. So there is potential in the desalinization of the ocean's water, which is a hopeful alternative, which is even better when it is powered by renewable green energy. Data centers, of which we are getting more, need to be cooled, and there are some other ways, like the liquid immersion cooling system, of cooling the centers rather than using heaps of water. In the face of growing freshwater scarcity, the environmental challenges, sustainable solutions are vital. Desalinization and immersion cooling showcase the potential to revolutionize water management and data center operations. By tapping into the ocean's resources and embracing innovative cooling technologies, we can usher in greener, more sustainable era where technology and responsibility coexist harmoniously.